Hello, viewers. In today's session, we are going to discuss another important problem from integrals. And in this session, we are going to find out the value of this definite integral using the concept of beta and gamma functions. Right. So here we'll see the application of beta and gamma functions to evaluate this integral, right? So here we have the integral from 0 to 4 x raised to 3 by 2, and here we have 4 minus x raised to 5 by 2 dx. So first we'll convert this integral into a beta function by using the method of substitution. So let us start. So let us first call this integral as I, right? And here we'll make this substitution, that is x is equal to 4 times t, right? So here we are using this substitution because we wish to convert this integral into this form, that is the beta function, that is beta m comma n, and here we have 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So making this substitution, will first convert this integral into this form, and then we'll apply the relationship between beta and gamma functions, that is beta m comma n is given by gamma m gamma n divided by gamma m plus n, right? And moreover here we'll also utilize these two important results, that is gamma n plus 1 is given by n factorial, where n is some positive integer, and gamma n plus 1 can also be written as n times gamma n, right? So let us make this substitution. So here x is equal to 4t, so t can be written as x over 4. Now let us differentiate x with respect to t. So we can now write dx over dt is d by dt of 4t, and we have 4 times the derivative of t, and derivative of t with respect to t is 1, so we have 4. So now dx can be written as 4 times dt, right? Okay, now let us change the limits, because here x varies from 0 to 4, and here we can find out the value of t using this relation. So when x is equal to 0, then t is 0 over 4, that is 0, and when x is 4, then t is 4 over 4, that is 1, right? So now let us write this integral I in terms of t. So we can now write the limits from 0 to 1, because when x changes from 0 to 4, t goes from 0 to 1. So we have here 0, here we have 1, and x raised to 3 by 2. So x is given by 4 times t. So we can now write 4t raised to 3 by 2. Then we have 4 minus x is 4t raised to 5 over 2, and dx is given by 4 times dt, right? Okay, now let us arrange the terms or simplify this expression or integrand. So we have 4 raised to 3 by 2, and then t raised to 3 by 2. So distributing this power to 4 and t, and here we can take 4 common. So we have 4 minus t raised to 5 over 2, and here we have 4 dt. So now we can write 0 to 1, 4 raised to 3 by 2, t raised to 3 by 2, and then this exponent can be distributed over 4 and 1 minus t. So here we have 4 raised to 5 by 2, 1 minus t raised to 5 over 2, and here we have 4, which can be written as 4 raised to 1, and here we have dt. So now let us first collect these 4's, right? So we have I is equal to 4 raised to 3 by 2 plus 5 by 2 plus 1, and taking this term outside the integral, and then we have 0 to 1 t raised to 3 by 2 1 minus t raised to 5 over 2, and here we have dt. So now this expression is equal to 4 raised to 5, because here 5 plus 3 is 8, 8 over 2 is 4, 4 plus 1 is 5. And we can now write 0 to 1 and t raised to 3 by 2. So 3 by 2 can be written as 5 by 2 minus 1, because we have to write this exponent, that is m minus 1. So we have to write 3 by 2 in this form, m minus 1. So 3 by 2 is 5 by 2 minus 1. And similarly, here we have 1 minus t raised to 5 by 2. And 5 by 2 can be written as 7 over 2 minus 1. And here we have dt. So now this integral is converted into this form, which is similar to the beta integral. So now 4 raised to 5 can also be written as 2 square raised to 5. So we have 2 raised to 2 times 5 is 10. So here we have 2 raised to 10, and here the value of m is given by 5 by 2, and the value of n is given by 7 over 2. So this integral is now equal to the beta function, that is beta 5 by 2 comma 7 over 2. And here it is quite obvious that 5 by 2 and 7 by 2 both are greater than 0 or positive. So now to calculate the value of this beta function, we have to make use of this result. So we have 2 raised to 10, then we have gamma m. Gamma m is gamma 5 by 2. Then we have gamma 7 over 2 divided by gamma 5 over 2 plus 7 over 2. So now the integral I can be written as 2 raised to 10. Then we have gamma 5 by 2 and gamma 7 over 2 divided by this is 7 plus 5 12. 12 over 2 is 6. So we have gamma 6, right? So now let us find out the values of these three terms using these relations. So gamma 5 by 2 can be written as gamma 3 by 2 plus 1. So here we have gamma n plus 1, which can be written as n times gamma n. So n is 3 by 2. So we can write 3 by 2 gamma 3 by 2. Then we can further split 3 by 2 as a half plus 1. So again, applying this result to gamma half plus 1, we have 3 by 2 times half, then we have gamma half, and gamma half is equal to square root of pi. So we have 3 by 2 times half times root pi, that is 3 over 4 times square root of pi. And similar is the case with gamma 7 over 2. This can be written as 5 by 2 plus 1. So we have again applying this result to gamma 5 by 2 plus 1. n is 5 by 2, so we can write 5 by 2 gamma 5 over 2, and gamma 5 over 2 is given by 3 by 4 times square root of pi. So here we have 5 by 2 times 3 by 4 root pi. So this is 5 times 3 is 15 over 8, and here we have root pi. And now gamma 6 can be written as gamma 5 plus 1. So here we can apply this result. So n is 5, which is a positive integer, so we have 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. So this is 120, right? So now let us substitute these values in this expression. So I can now be written as 2 raised to 10. Then we have 3 by 4 root pi. Then we have 15 over 8 root pi divided by 120. So now our aim is to simplify this expression. So we can now write I is equal to 2 raised to 10, and here in the numerator we have 3 times 15. That is, we can write 3 times 15. Root pi times root pi is simply pi, and in the denominator we can write 4 times 8 times 120. So now this is 15 times 8 is 120. So we can cancel 120 with 15, so we have here 8. So now we have 2 raised to 10 times 3 pi, right? 3 times pi, and here we have 4 times 8 times 8. So 4 can be written as 2 square, then 8 is 2 cube, then 8 is again 2 cube. So we can now write 2 raised to 10. Here we have 3 pi divided by 2 raised to, again applying the laws of exponents. So this is 3 plus 3 is 6. 6 plus 2 is 8. Right? So now the value of the integral I is 2 raised to 10 minus 8. So subtracting 10 and 8, and then we have 3 pi, and 2 raised to 10 minus 8 is 2 square, and here we have 3 pi. So 2 square is 4. 4 times 3 pi is 12 pi, right? So viewers, the value of this integral I is equal to 12 times pi.